Aloha friends, it's Mrs. Rankin. I've got my summer science notebook back out today, and I've got my list of ways that we can use our notebook like a scientist. And one of the ideas that I'd like to explore with you today is this idea of planning experiments and doing tests. We're going to also be recording some observations and perhaps even adding some notes and sketches. So here's a question I have for us to investigate today, something I'm curious about. How can an investigation with a lemon help me to understand how a battery works? It's coming to the end of the school year, and I know with my fourth grade friends at the beginning of the year, we talked about batteries and power and electrical energy, and I'd like to come back around to that discussion to see what my friends remember, and also to see if we can come up with applying what we know about this device to this device, which seems like the two are not at all similar. So in order to do that, I want to go ahead and enter my question that I'm interested in investigating. So this might be like my big question or my essential question. Sometimes I like to set it off, maybe put a little special box around it. I don't know. Some way to sort of set it apart. And then I'm going to use this side of my notebook for maybe some smaller questions. I'm going to pick this large question apart. So I guess the first thing I want to know is there any way that a lemon and a battery are alike? So that's maybe a first question. How are a battery and a lemon alike, if they are at all? So here's my lemon. I'm just going to do a quick little sketch. It's got sort of this little bumpy bit, little stem bit there, and a battery. I'll draw it right up here. A cylinder shape. So what are some ways that a battery and a lemon are alike? Well, I have some sort of an outer covering. This has a metal covering. Whoop. And this has a peel or a rind covering. What are they covering? They're both covering something. Any ideas about what's inside? Some kind of juice. Is there any kind of juice in here? Maybe if you've kept a battery in a toy or a device for a long time and you haven't used it, and then you go to take it out, you notice there's like some crusting around the ports, the terminals, the ends. It's actually caused by a leaking of the battery, isn't it? So there is some battery acid inside. There's some acid inside this too, isn't there? Sure is. There's citric acid inside. All right. Maybe we'll go ahead and stop there and look at where does this question lead us. If there's a battery and a lemon are alike in that they both are covered with something and they have an acid inside, what do we know about the battery? What do we know about how it works? We put it in things when we want them to turn on. So how do we know that the battery provides power? Do we know just because it says so? Because if we look at the outer casing of the battery, we can see the date it was made, and we can see 1.5 V or volts. So it's supposed to be 1.5 V. Volts. So volts, remember, that's just the push that the electrons experience. It's a measure of power. Now, I can take this battery and I can hook it up to an instrument called a multimeter. We've used this in class before. Perhaps you've got one at home. They're helpful for seeing how much voltage a appliance might be using. So I'm just going to go ahead and hook up this multimeter to the battery and see if 1.5 volts is in fact the voltage that it's producing. Now we've got our multimeter. We'll go ahead and hook up the leads. And we have the voltage turned to the 20 dial. And here's my battery. I've got the positive and the negative lead. And I'll just go ahead and attach that to the positive and the negative end of the battery. And then look at the meter. And we're getting about 1.59 volts. All right, so this is how we can test to see how much voltage the battery is producing. All right, let's just go ahead and slide that off for now. So use a multimeter to test the voltage of the battery. Okay, and in this case we have 1.59 volts. That was our reading. All right, terrific. So if we know that there are some similarities and that both have an acid inside, and we know that this battery produces 1.59 volts, I guess my next little question is, does the lemon provide any power? How could I test that? How could I use the multimeter to test the voltage of a lemon? That's a crazy question. Any ideas? It doesn't have metal leads. It doesn't have a metal covering. And I know that if I connect the multimeter to something that's insulating, to something that doesn't conduct power, doesn't allow electrical current to run through, that I won't get any reading. So I'm going to need to add something to this lemon that will conduct any power or voltage that is able to be created. And that something is going to have to be a conductor. So what are some materials that are conductors? All right, so we have this lemon. With a peel and a stem. That's probably not a conductor. We're going to need to attach something that will conduct. So I've got some pieces of metal here. There are two different metals. I have a piece of copper wire. And if you don't have just a length of copper wire at home, you might have an old broken set of these kinds of holiday lights. I keep them around to do things with the bulbs. But the wire inside this insulating rubber is copper. So you could strip that away and use some of that, a bundle of that copper wire, if you don't happen to have just a piece of heavier gauge or thickness. But since I do, I'm going to go ahead and put that in there. And then on the other side, I'm going to use just a galvanized iron nail. So this is a nail that has been dipped in zinc. I'm going to go ahead and put that in the other side. So let me make a sketch here. I've got some copper wire. Copper is Cu. And then I've got a nail that is zinc dipped iron. All right, zinc. So now I've got something that I can attach the leads of my multimeter up to. So let's bring my multimeter back into the picture and get ready to do just that.